This video, we're going to talk about some more problems from A.7. This time, we're going to express exponential expressions containing positive rational exponents with a numerator that's not equal to 1 in radical form. So we're going to use the rule that x to the m over n is equal to the nth root of x to the m. That's our big idea for this video. We're going to do problems from A.7 like numbers 17 and 21. Just a couple examples of this. So 16 to the 3/4 power is going to be the 4th root of 16 to the 3rd. So I want to see if I can write 16 with in its prime factorization. So let's go ahead and let's do that. This is 16, which is 4 times 4, still not its prime factorization. 2 times 2 times 2 times 2. So this is 4th root of 2 to the 4th raised to the 3rd. And you can see that because x to the a raised, or let's call this n, to the n raised to the m is equal to x to the n times m. And because multiplication is commutative, I could switch the order like that, and I could rewrite it as x to the m raised to the n like that. I'm going to switch the places of these exponents. It doesn't change anything with the problem that 3 times 4 and 4 times 3 are the same thing. But what I see here is this is 4th root and this 4th power now are going to make each other go away. And this is 2 to the 3rd, which is 8. I also have the option of making the 16 bigger to start off with, but I would not have seen very easily what 16 times 16 times 16 was. I would have had to have used my calculator for that. I think that 16 times 16 is 256. Then after that, I'm kind of lost what times 16 again is because I don't normally go that big. 33, 15, and 256. 10, so 40, 96, and then good luck factoring that. But apparently this was 8 goes into this 3 times, or 4 times, excuse me. So this was apparently 64 times 64. And that was 8 times 8. And another 8 times 8. I don't like to make the numbers bigger to then try and break them down. I try and make everything small and then see where I go from there. Another thing that we can do, we can use the fact that this is a rational exponent to our advantage. The reason that we write it as a fraction is because I could have seen this as the 4th root of 2 to the 12th power. If I think of that as 2 to the 12 over 4, oh, I know what 12 divided by 4 is. That's 3, and that gets me to the same place that this is 8. So it might help us to go back and forth. Sometimes it's easier to think of the problem with roots. Sometimes it's easier to think of the problem as a fractional exponent, but we get to the same place. Let's look at the one that's like number 21 now. Negative 81 raised to the 3/4 power, like the fourth root of negative 81 to the third is the fourth root of negative 81 to the third. And I can stop there because I have a negative number inside of an even root. And I can answer this question that the answer is not a real number. We'll come back later and we'll talk about so how to write some answers that aren't real numbers. But for right now, we need to know that anytime that we have an even root, the number underneath the root must be non-negative. So for the nth root of x, if n is even, x has to be greater than or equal to 0. That's going to be one of our rules for something that we're going to call a domain later. So one of our rules that we already probably know about domain is that we aren't allowed to divide by 0. And now the next thing that we've learned about domain is that we can't take the square root or the fourth root or the sixth root or any other even root of a negative number. All right. We'll come back next time and we will approximate square roots, and we'll do it using our calculator. So show you how to do that next time.